Good morning, everyone. I set an extension for quiz number 10 for you guys if you want to get to it. Some of you, reported to me you have some trouble getting that done for one reason or another. So that quiz is due tonight, midnight. Okay, so an extension is set for you. So please, get it done. It's very, very important for you to have that quiz done to fully understand the definition. Of course, we're not done with the definition yet. And today we're going to continue the conversation on from ARD to definition, from ARD to definition. Okay, so let's continue. So last time we talked about that the ratio, which is y over r for sine ratio, sine of any angle is the y coordinates of the point, right? Remember ARD, shall we review ARD? A is the angle measurement, okay? And R is reference angle, right? And what is D? Definition. So we are in definition. They come in that order because you have to have that stage. You have to have the proper stage set before the definition can be introduced, right? So after the definition is introduced, right, then we know which symbol represent what, right? We know which symbol represent what, right? So you know that what it means. What are the possibilities of measuring the angles, right? So ARD are inseparable. They are in one system, in this one system. So from ARD to domain, these topics typically are scattered in different chapters of trigonometry, okay? Angle measurement was introduced first. Okay, angle measurement was introduced first, and then definition was introduced. At least that's the trig function, the trigonometry textbook I have in front of me. Well, depend on how your teacher taught you, right? These three concepts are not together. They're not together. The angle measurement was actually introduced first, and then they introduced definition. You can see here, I look at this trig definition, a textbook, right? Angle measurement was introduced, and then definition was introduced. But reference angle was not introduced until chapter 3, I believe. Okay, I taught this I think I taught this with this textbook. Reference angle was introduced in chapter 3. Okay, so depending on how your teacher teaches these topics, they're not together, but they should be together. They should be together. Okay, but because of that separation, okay, for many reasons, because there's a lot of contents to be covered in between. For example, the author has its own reason for writing it that way, because you cannot cram everything in one place, in one chapter, right? For various reasons. That's why it's needed for us to study across the chapters, right? So you first study chapter by chapter, chapter 1, chapter 2, chapter 3. And then after you're done with chapters 1 through chapter 6, for example, you're gonna have to across the chapter, you have study across the chapters. Do you guys follow me? I'm talking about methods of study, pretty much related to any subject. So with that said and done, the domain of trig functions, I believe in this textbook was introduced in chapter 4. Yeah, in chapter 4. So these things are separated, but almost everything, every important property, they were all originated from the definition, So if you hold the key of definition, right, after A and R, and everything will become so obvious and become so connected, become so, it's just evident to us. So we no longer have to memorize those dry facts. Okay, so let's review, how does ARD take us to domain, right? So with that setting, we know that we have a point, right? What's the narrative in definition? What's the narrative in definition? Let's review this. Let's review the definition, right? ARD. Is everybody awake?
Yes.
Okay, so what's the definition? In the definition, we pick a point arbitrarily on the terminal side of the, on the terminal, other than the origin. So this is the point on the terminal, right? And this point has an x coordinate, right? Which is right here. This is how much is x, right? This is how much is x. And we have a y. And this is how much is y. So x and y, visual. That's the visual xy. And what is r? With this right triangle formed, right? We have x, whoops, wrong color. We have y, we have x. Knowing these things are so important, okay? I remember when I had a student who was a TA for a calculus class. He came to me, he was asking, well, this is about calculus 2, right? So we have this figure, we're gonna rotate. So when you rotate, right, remember, think about this. Suppose you have something like this. Do you guys see this pen? Do you guys see this pen?
Yes. Yes.
If you rotate, right, you need to know the radius, right? Because you're gonna rotate, right? Right? You're gonna rotate. Does that make sense? You don't have to take calculus 2 to understand this. You have something like this and you're gonna rotate, right? You're gonna form a circle, right? A disc, something like that. So you need to know the radius. But if you understand the basics of x and y, this is x, this is y, visual. In your calculus 2, they tell you, I'm going to rotate about x-axis, I'm going to rotate about y-axis, I'm going to rotate about this and that. Knowing this is x, this is y is essential. So that TA I was just talking about, he just basically forgot about this. And then I pointed out, so that this is x, this is y. Oh, then he got it. That's how essential the basic concept is. Okay, we don't need to go very far. You just have to understand some definition, some theorem. Just spend some time on it. So I'm showing you how you should study your calculus courses. All right. So without further ado, right? From this definition, and we are also told the R, right? So now everybody knows the R. The R is basically the hypotenuse, right? The hypotenuse. That's the R. That's the R. So visually or common sensely, you know that Y will never be longer than R, right? at most is equal length, right? And x as another leg of the right triangle will never be longer than r, and will never be what? Will never be longer than r. Well, at most, it's same as r. What happens if x is the same as r? Well, this will no longer be a triangle. It will be just a straight line. Could that happen? Yes, that could happen. Now, the next thing is that we realize, right? So I'm gonna write it down here. You see this from some of the basic facts, okay? So what I'm going to do is I'm going to explain the geometric observation at the same time. I'm going to introduce the algebraic expression, which you need that very much, okay? All right, so let me clean this up. I may have to redraw these things, right? So over here. Is everybody with me?
Yes.
Okay. I just make the font just a little bit smaller. Okay, so some of the basic facts is that we're speaking about just from the definition, okay, just from the definition. Okay, so your focus is look at the correspondence between the geometric observation and its algebraic representation. Okay, algebraic representation. So what we just talked about, that if this is x, okay, this is x, right? Are you guys drawing those things on your paper? Please do. And that's y, right? So this is y, and that's x. That's x. And these are r. Okay, you may say, hey, this point is in the first quadrant. Wait, we'll see what happens in the second quadrant. Okay. Now, we notice that y will never be more than r for any angle. Okay. And x will never be more than r, right? You agree? Yes? Right?
Yes.
Any angle you measure, if the terminal ends up in the first quadrant, right? Now you say, well, what if, remember when we were doing the quiz, you know that the terminal could end up in the second quadrant, third quadrant, fourth quadrant, right? What will happen then? What will happen then? Right? So the terminal could end up in any quadrant. So all things has to fit, right? All things has to fit. So what will happen? Let's see. I'm going to give you another point. Okay. So I'm going to add another point, add another terminal, right? It could be this terminal. It could be that terminal. It could be that terminal. It could be in every different quadrant, right? It could be in every different quadrant. In the second quadrant, x will be negative, right? X will be negative. Remember, r is always positive. R is always positive. Okay. If x is if x itself is negative, for example, it's going to be, this is going to be true anyway. Okay. However, does x have a bound? Right? Does x has a bound? Or does y has a bound? What is the largest x? What is the largest y? Okay. Before we do that, before we see this general form, I think it might be a little bit difficult for us to see. I want you to see that is special unit circle you guys are all familiar with. Okay, I'm going to bring this up. I'm going to bring this up. Unit circle. You guys see this unit circle, right? When you see this unit circle, what does that mean? Does everybody understand what that unit circle means?
Yes, but do you think you can make it a little bit bigger? We can't see the, or yeah, we can't really see the pies.
Can you see that?
Yeah.
But what's the narrative about the unit circle? Okay, so I'm gonna put this away here. Just put it here. Okay, so let's look at the narrative on the unit circle, because most of the time we use the unit circle, and I assume you guys know the unit circle, right? So let's look at the ARD on the unit circle. A is the same, R is the same, D, right? We have talked about why we choose unit circle, because units, if you choose the points on the unit circle, if you basically that key sentence in the definition, what is that key sentence in the definition? We choose any points on the terminal, right? Could you guys write down that? These are the thought process. Okay, I'm going to give you exactly the same sentence. And people say, how do I study mathematics? This is how you study mathematics, guys. Okay, it's a process. It's a patient process. Okay, it's a patient process. It says A is the definition on unit circle, right? So A is an angle in standard position. Okay, and the point xy, is any point on the terminal. Is any point on the terminal. On the terminal side of A. Terminal side of A. On the terminal side of A. Am I too slow? Are you guys okay? Other than the origin. Other than the origin. Okay? And then blah, 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 the definition of 6 triangles are being defined, right? So where's that definition? We had it. Right? So we have that definition. Right? So we have that definition. Okay? With that definition, then you say, where does that point on the unit circle fit in? We talk about, because these are ratios, it doesn't matter where the point is as described. So if the point xy is on the unit circle, the ratios defined in these functions will be the same, no change. So on this unit circle, what are the points? How are the points relevant? The points can be, all of these are possible points of xy. Are you guys with me? All of these are those points. And you can just keep going. Do you guys understand? So these points are the x, y, because it doesn't matter which point is chosen on the same terminal. We chose the point on the unit circle. That is the narrative. That is the logic. Do you guys follow me? Yes?
Yes.
Okay. So from this perspective, from this perspective, what we're going to do, you can see all of these blue numbers. All of these blue numbers are possible values of y. Okay, all these blue numbers. Okay, all of these blue numbers, right? Because we talk about y, right? What's the meaning of y? Y over r. Y over r. Okay. R is equals to what?
1.
R is equals to 1 because it's a unit circle, right? So any angle you have, because R is equals to 1, so y over r is just y. So the ratio is the y. And the ratio is y, meaning what? These are the blue numbers, right? This is 0. Another blue number, right? At, you know, when you have a terminal here, your terminal, this is your terminal, pi over 6, right? And the blue number is right here. This is half. And this other blue numbers, right? And this other blue numbers. All of these blue numbers, those are the y values. Those are the y values. None of these heights is more than 1. Do you agree? Do you agree? This is 0. So this is a positive one. You see the largest blue number is what? The largest blue number is sine A. The smallest blue number is sine A as well. It's just at a 270 degree or 3 pi over 4. So what does this picture tell you? This picture tells you y is less than equals to 1, larger than or equals to -1. So that's domain range in one sentence. Do you guys see that?
So wait, -1 sine A. So this whole entire thing you go down, that's the domain.
This is the range. This is the ratio. Ratio the output. The largest output is the blue number 1. The smallest blue number is -1. And all the other blue bars in between. Do you guys see that? That's the visual. Do you guys see that?
So, Professor, the domain is the angle A.
Domain is the angle. The ratio is a blue number. Domain is angle. Okay, you measure. This is the angle. You measure this angle.
And it can be all real numbers.
Okay, so that's domain. Domain is about this angle, right? How do you get those angle? So let's do it again. Domain is about angle. You measure from the standard position any angle, right? And there's a terminal. On this terminal, there's a y. There's a y. This is a y. And this y is the sine ratio. So this is the input and this is the output. Do you guys follow me? The input is angle, the output is a ratio. The ratio is a y. You guys follow me? Okay, let's do it again. Yeah, that's why I emphasize input output, because every function has a rule. You have to understand the rule, and these functions are the most complicated basic functions you are ever going to see. Okay, so every angle is measured from the standard position. Didn't we talk about that? That's A, right? That's A. This angle measured Okay, this angle, it has a terminal. It has a terminal. This is the terminal. And this is A. This is angle A. Okay, what is sine A? Sine A, according to definition, you pick arbitrary point on the terminal. Now this time I pick one on the unit circle. What is the output for sine A? The output for sine A is this guy. Is that clear? The input is angle A. The output is this vertical bar. Does everybody see that? Okay. Shall we do breakout rooms? Let's do a couple more, okay? Let's do a couple more before we do the breakout room if necessary, okay? Now, so this is one angle, right? So let's do another angle. Okay, I'm gonna clean this up. Another angle I'm gonna measure from the standard position, right? Terminates over here, so this is the terminal. So that's the terminal. Okay, I'm trying to let it like a little bit off the special angle, okay? They don't have to be special angle, okay? And now, what is the ratio? Sine ratio. Sine ratio is y, right? If you choose a point on the unit circle. So I'm choosing this point on the unit circle. And what's the y coordinate of that? Is this guy. It's between between two blue numbers. Yes? So this is the input. This whole big angle is an input. And this is the output. Okay, so this is the input. And that blue height is the output.
Professor, can we say the blue line output is the vertical component of the output? Therefore, we can remind ourselves it has a also horizontal.
Is the vertical coordinate of the point on terminal. That's what a y over r means. That's what a y is on the unit circle. Yes? Let's look at another point. Okay, let's look at another angle. This time, the angle is measured from standard position. Okay, I can measure any way I want, counterclockwise, clockwise. We have talked about it. It doesn't matter how you measure. For one terminal, you have as many as possible angles that ends up there, right? So this angle, right? That's the A. It's going to be a negative angle because it's measured clockwise, but no matter. It could also be measured the other way, right? We'll go around and around many times because it's going to end up here. And we pick a point on that terminal. And this point has an X coordinate, has a Y coordinate, right? And we use the Y coordinate for what? For the output. So that's the input, that's the output. Is that clear? So input is the angle. The output is the Y coordinate. It's a Y coordinate of a point on the terminal, on the unit circle, or the ratio of the y coordinate on the terminal over the length of the term that description is going to be too long. Okay, so let's still focus on the unit circle. How about that? I don't want to give you just too complicated. Okay, if I give you a too complicated sentence, it's going to confuse you even more. Okay, so now we're focusing on the unit circle. On the unit circle, the ratio is y. Okay, because the radius is 1, ratio is y. And the point on the terminal is chosen to be on the unit circle. So that's the input. And that's the output. Does everybody see that? Input is angle, output is ratio. And what is the ratio? Under the circumstances, this is a simplified version of it, is the y coordinate of the point on the terminal and on the unit circle. Did you get it?
So Professor, output or range depends on the type of the trigonometric function. So if it is sine, therefore the output is vertical component. If it is cosine, then it is a horizontal
Right.
component.
Right. So now we're not
Also-
talking about cosine. We're just talking about sine.
Yes.
Okay. So now let me ask you another question. Let me ask you another question. Sine of pi over 6. What does that equal to?
1/2.
1/2. What is the input? Pi over 6 the input. What's the output? Half of the output. What is pi over 6? Pi over 6 is the angle measured from the standard position with a terminal over here. That's a terminal, right? Pi over 6. So this is A. This is A. And what is the half? What is half?
Y.
Half is 1/2. This is a half. This blue half is here. You see, A is angle, ratio is half. Same thing. You guys see that? Do you see that?
Yes.
If you understand this, and that's what we're saying exactly here. And of course, you can do the fourth quadrant terminal, right? You can do the fourth quadrant terminal. So if you understand sine pi over 6, you understand pi over 6. And pi over 6 is a measure from standard position counterclockwise with the terminal right here. This is the terminal, and the terminal across the unit circle has a point. And this is the point. The blue number is the ratio for sine, and that's how high it is, half. Is that clear, everybody? So now you can see the input-output relationship is slightly different on the unit circle, right? So with this understanding, if you do every one of them, maybe for Ruth, we should do a breakout session, right?
That's a good idea, Professor.
Let's do this. This is essential to understand because this is going to lead us to the graph. This is going to lead us to the graph. So let me clearly specify what I want you to do. Okay, what I want you to do. We're just doing it for sine. Okay, don't do cosine yet. Don't do cosine yet. We use definition. You have your definition card next to you. Okay, But in particular, we're going to choose, because we can choose any point on the terminal, therefore we just choose the point on the terminal intersecting with the unit circle. How about that? So this will guarantee a simple radius, that radius equals to 1. So make our life easier. Okay, so in the whole process, I want you guys to reflect on this. Okay, so what I want you guys to work on, what I want you to work on to understand this process, right? So if you have a pi over 6, right, this angle, this angle A, and the ratio is the blue number. And what is the visual of that blue number? The ratio of that blue number is half. Half of 1. Okay, so this blue number is half. Okay, so what I want you guys to do, you pick up any one of these points, choose 3 points, and you go through this thought process. You go through this thought process. Okay, for example, I can measure another angle. Okay, it doesn't matter how you measure it. You can measure clockwise, counterclockwise, right? This is my angle. Okay, and the terminal, now we just work on the special angles, if you wish. Okay, after 3, you can work on a non-special angle, okay? So this angle, and that's your A. That's the A. What is the point on the terminal intersecting with the unit circle? And that's the point, -1 over √2, -1 over √2. Okay, the blue number is this height. Okay, and that height is the blue number. You follow me? So you're going to do this. You just mentally do this. I'm going to give you 5 minutes. How about that? 5 minutes sounds good enough?
Yes, Professor.
Okay. So you're going to choose 3 points. You don't have to choose many more. If you want, you have time left, go for it. Just reflect on this rule. Reflect on this rule. A is the angle. Wait, sorry, I clicked on the wrong place and I lost everything. Sine of A, the output is sine of A equals to y over r equals to y when r equals to 1. Reflecting on this relationship. Would you guys do that? 3 points. Yeah? Focusing on the input, output. Do you guys follow me?
Yes.
Okay. Breakout rooms. Okay, I'm going to redraw the picture. Okay, I'm going to redraw the picture by setting up the breakout room. You still self-designate your, if you want to go to with Farouz. Okay, so I'm going to be, okay, so I'm going to draw one more example. Okay, angle measured, terminal. That's a terminal. Okay, and what is the blue number? And that blue number is is this guy. Okay, and that's the A, which is the input. Okay, this number is output. The blue number is output. Okay, with the blue one is the output. It could be positive, it could be negative. Okay, you can stay with me. Okay, if you have any questions, please don't hesitate to ask. Measuring another angle. Okay, I just like to measure clockwise, and I can. If I can, I will do it, right? And this terminal, and pick a point on the terminal, on the unit circle, and this point is this guy. Okay, and the blue number is, so this is the input, and that's the output. How high is the output? This is how high is the output. Is that blue number indicated? It's the blue number, which is -√3/2. It's a negative number. You see, it's beneath x-axis, so it's a negative number. That's the output. Okay, so that's the input, and that's the output. For sine, okay, for sine. So for those of you who stayed with me, are you guys doing it? It's essential for you to understand this. You see how much we can dig out of the definition, right? And when you're in calculus class, this is required that you have to dig if you want to get that A. You're going to have, you know, several major definitions, limit continuity, differentiability. Okay, and for each of those definitions, okay, each exercise you do, each question on the test, they are all about these three major concepts, especially for Calc 1. The next definition, which is integration definition, comes in chapter 5. It's you know, it's a more complicated situation, but it still has its own definition. Definition is super duper important. Okay. If you don't understand the definition, you always get lost. You always get lost, for sure. I have been there many, many times. I have been there many, many times. All right, you guys, do you have any questions? Are you guys playing with it?
Professor, I'm back and I can see breakout room. If any student go breakout room, I can join the breakout room.
Oh, okay, so nobody went. But that's okay, we tried. Maybe everybody already got it, right? Can you guys give me some feedback if you got this? Can you guys give me some feedback, or could I assume, because nobody said anything, I can assume either none of you get it or everyone got it? Yes? You can see the input, you have to measure the angle, right? You have all these different ways to measure the angle, counterclockwise, clockwise. And the ratio is a blue number. You see, ratio is a blue number. All right, can I safely assume you got it? Because we can get any angle we want, right? No angle we measure will cause a zero denominator, right? Will the denominator ever be zero? No, the denominator will never be zero, right? And the blue numbers, if you look at all the blue numbers, right, on this unit circle, this is just a finite number of blue numbers. Imagine there are other blue numbers. There are a lot of other blue numbers in between the blue numbers. Do you follow me? There are many blue numbers in between the blue numbers, which are those non-special angles, such as those you've done in your homework. There are lots of other blue numbers. All of these blue numbers considered, what you can see and what you can imagine in between the blue numbers, there are infinite number of them. What do they have all in common? They are between -1 and +1. That is the range of sine. You get it?
Yes.
So now you look at that unit circle. Do you see more? We should, right? Because all the angles considered, right? This is one of the sine ratio. This is one of the output for sine. Another output for sine. Another output for sine, right? This is the highest output for sine, right? And you keep going. And sometimes the output for sine could be negative. And the negative is reflected because it's underneath the x-axis. Another output, this is not special angle, another output. And the smallest output is -1. Everything else, every other blue bars is in between. What can we say? That ratio is always between -1 and +1. Yes?
Yes.
And the algebraic expression of this observation is what? What is the algebraic expression? The algebraic expression is right here. That's what it says. Sine of A, which are the blue bars on the unit circle, and those blue bars are between -1 and 1, no matter which angle you measured, right? You have many more angles, but none of them, okay, special, non-special, all of them are between. You guys follow me? That's why we say picture tells 1,000 words, but you really have to dig to dig out those 1,000 words. So that's for sine. Okay. Any questions? Any questions?
I have one quick question.
Go ahead.
What if you did sine of pi?
Sine of pi. All right.
Would that be 0?
Yeah.
Okay.
Sine pi is 0. Right? How so? You measure pi, right? You measure pi from the standard position, and here's your terminal. Your terminal is the other side of x-axis. So that's your terminal. I pick a point on the unit circle. You see, this is pi, right? This is a terminal for pi. And then you pick a point. You pick a point on the terminal crossing the unit circle. What's the coordinate of this point? -1, 0. And 0 is sine pi. Did you hear I'm applying the definition?
Yeah.
See, you apply the definition. Definition is super careful, it's super useful. Right? And this is and this other terminal Not only this is for pi, for 3 pi, 5 pi, 7 pi, you just keep going. Right? One terminal could represent many, many points and many, many angles. Could be terminal of many, many angles. We analyze that, right? So far, so good?
Yeah.
Now, you can see if we do the unit circle, right? We can find the information we want. Pardon me, I'm gonna have to pick up this phone because this is from a doctor's office. Sorry about that. Okay, all right, let's keep going. Do you guys understand that? But what this does is this lead us to the sine curve. This lead us to the sine curve, right? So first we got this very important relationship, which is about domain and range. Okay, so this expression says, no matter what the angle, sine of any angle is always between -1 and 1. Okay, always between -1 and 1. Okay, so let me put the narrative. Sine, okay, let's first write the function f of x equals to sine of x, right? This is, you're not going to see a in calculus. They're going to use x, okay? The domain is all real numbers, and the range, there are 3 forms, 3 major forms. This is the one form, and there's another form with absolute value. Okay, let me use x here. Less than equals to 1. Okay, the last form is a -1, 1. Most of you probably know this, but what's really useful for you are the first 2. Do you guys follow me? In particular, the first one. If you don't know how to use this one, you're going to lose 10 points on calculus 1. Guaranteed. I guarantee you. Okay? You're going to lose 10 points. Okay? Knowing this is fine, but you really need to know these 2. So that's why we're going to use these 2 intensively in classes over and over again until you get it. And we just explain the meaning, right? We just explain the meaning. Anybody has any questions about it? In our course, I use A for in place of X because I want to emphasize ARD. I want to emphasize ARD. Okay? Same meaning. It doesn't matter what symbol is behind. Doesn't matter what symbol behind. The next question would be, since, you know, in order to do the input output for sine function, we have to, you know, measure the angle, find the coordinates. That seemed to be just a lot of work. Can we set up a direct relationship? Can we set up a direct relationship between input and output for sine? That leads us to the graph. Okay, so what I'm going to do is I'm going to take this unit circle. Okay, I'm going to take this unit circle, and then I'm going to do the sine of A. We know the domain and range already, right? So we have sine of A we want to establish a direct link. Okay, A, okay, and sine of A, right, which is Y on the unit circle, right? So we're going to set, we want to see We want to see input output in the sine relationship. So A is the input, Y is the output. Okay, the Y I meant the blue number. You follow me? So we want to set up that relationship. We want to set up that relationship. So in order to do that, so we're going to set up a rectangular system. We're going to set up a rectangular system. This rectangular system, in this rectangular system, let's see how we set it up. Okay, let's see how we set it up. Suppose I'm going to start with something simple. Okay, I'm going to make some adjustment to the picture just to get started, to keep things simple. Okay, so what's the meaning of the horizontal? The meaning of the horizontal is going to represent the measurement of angles. So this horizontal relationship, right? Remember, the horizontal always represent the input, right? The vertical always represent the output, right? Yes?
Yes.
So this, like all the functions we've done before, they are all being done that way, right? Input, output. What's the input? Input is horizontal. Output is what? Is vertical, right? Up or down, right? So this is the input, which are angles. And these are the ratios. So these are the ratios. The ratios. What kind of ratio? Of course, for sine ratio. Are you guys with me? All right. Now, excuse me. Because we have chosen the unit circle, there's another very, very interesting relationship is that, for example, if I measure pi over 6, right? And that terminal, there's a terminal. Okay, so my terminal is this guy, right? So this angle is pi over 6. This angle is pi over 6. So how do I put angle and ratio? Because on the x-axis, those are lengths. Those are lengths. How long, right? Positive lengths, negative lengths. Negative lengths represent clockwise measurement. So what happened is that if we have the point that if we pick the point on the unit circle on the terminal, the arc length. What is the arc length? You measure from the standard position. This is the arc length. Do you guys follow me? The arc length. The arc length. This is the arc length. Do you follow me? This is the arc length. Are you guys with me? My drawing is kind of awkward. This piece on unit circle, this piece is called arc length. Okay, this piece of arc length is going to be the same as pi over 6. This is pi over 6. So the angle is pi over 6. The arc length is also pi over 6. Does everybody follow me? So I'm going to take this arc length to be used as a length on this horizontal direction. So I'm going to take this arc length and stretch it straight, make it straight, right? Because we know that arc length is curvy, right? So I'm going to make it straight. Okay, I'm going to make it straight. And I'm going to measure exactly the same arc length. I'm going to make it straight. I'm going to measure exactly the same arc length. It's about the same length. So this piece of orange and this arc length orange, which is pi over 6, are exactly the same. Do you follow me? So that's my input measured from the origin. Okay, and the output, I'm going to take the blue number. The output, I'm going to take the blue number. The blue number is half. Do you follow me? Let me redraw this, okay? The blue number is half. So this point, what is this point? This point is marked as pi over 6, comma, half. Do you guys follow me? So I extract these two numbers from the unit circle. Okay, the arc length, which is the same as the radian measurement of the same angle, of this angle, because every angle corresponds to an arc length piece. And this arc length piece will be used as this length. So this blue curve is the same length as this straight orange, the orange, did I say orange? This orange curve is the same length as this orange straight line. That's the arc length of this unit circle piece. And half is the blue number. And we're going to do this for every point on the unit circle. Do you follow me?
Yes.
And let's do another one. Okay, let's do another one. Next, we're going to do, we can do pi over 4, right? We can do pi over 4. Do you guys know what's pi over 4? 45 degrees, right? Yes?
Yes.
45 degrees, okay? So we measure another angle. So once again, we're gonna have a terminal. That terminal ends up here, right? And there's an arc length. The arc length is also measured from the same position. So this piece, so this piece is stretched straight. And we're gonna measure the same from the same origin. So that's gonna be my pi over 4. Okay, and what is that blue number? 1 over root 2. 1 over root 2. 1 over root 2 is larger than pi, larger than half. Okay, it's about 0.7 something. Okay, so this point, and I'm going to mark that point. Okay, I'm going to mark that point, and that point is going to be pi over 4, comma, 1 over SQRT of 2. Do you guys follow me? And you do this point by point. Then you say, how about the negative angle? The negative angle, suppose I measure a negative angle. If I measure a negative angle, say I measure negative pi over 3, okay? negative pi over 3 is also going to measure from the same place. You see, all the angles are measured from the same place, right? Recall A, right? ARD. ARD means every input angle for these trig functions are measured from the same place. All right. So next, and the terminal right here, right? So this arc length, there's an arc length here. So now the arc length is also measured from the same place. Oh, sorry. Arc length. So this arc length is also measured from the same place. So this curvy piece is measured clockwise. Therefore, it's negative. So I'm going to stretch it straight. I'm going to stretch it straight and go to the negative direction of pi over 3. And then I take my blue number. What's that blue number? Negative root 3 over 2. Negative root 3 over 2. Right here. Okay, so that point, what is that point? That point is going to be negative pi over 3, negative root 3 over 2. And you keep doing this, you connect the dot, you connect the heart red dot, you connect the red heart dot, you get the sine curve. That's how you read the sine curve. Do you guys follow me? Everybody knows the sine curve, right? If I ask people to draw the sine curve, everybody can draw the sine curve. Do we know the inside story? But once you know the inside story, you know the inside story. You know how to read the curve and where it came from. And then you say, how about I go around and round? No problem. You just measure all of those arc lengths. You just add up all those arc lengths, right? For example, let's take an angle more than 2 pi. You go around and round, right? Measure another angle. Measure this angle. How much would that be? 2 pi plus pi over 6, right? 2 pi plus pi over 6. How much is the arc length? From here, the arc length is going to be one circle, which is 2 pi plus pi over 6. So that orange color, this piece is going to add 2 pi. And how do you measure that? You take that piece of arc length, you make it straight, you measure, how much you're going to measure? From the same place, 2 pi plus pi over 6. You ended up there. Okay? And then the blue number, what's the blue number? Half. The blue number is half. Do you guys follow me? And that point is 2 pi plus pi over 6, comma, half. That's the point. You got it? Are we ready to see the sine curve? Let's do this all over again with a real sine curve. Okay, are you ready? Are you ready?
Yes.
No response. Got one, thank you. Now I'm going to put the sine curve in the picture. That's a sine curve, right? Everybody knows that, right? Now, make sure these lengths are comparable because you want to make sure the lengths are comparable, right? So that's my one, this is one, and this is one. That's a comparable. That's one, that's one. So what I'm trying to do here, I try to make the lengths comparable, right? If you have different scale, it's going to be hard to recognize, right? So now let's do this one more time. Okay, for pi over 6, pi over 6, pi over 6, we use pi over 6 too much, haven't we? Let's use something else, pi over 4, right? Pi over 4. Let's use pi over 4. Pi over 4 is measured from the standard position, and that's the terminal. And the terminal has a point crossing the unit circle, and that point has a blue number, right? And that blue number, so my input is going to be the arc length. So I'm going to use this arc length. I'm still going to use the orange color, okay, for consistency. So arc length. Ah, my hands, my hands. Is that good enough? That's the arc length. This arc length and this angle are the same number, but arc length is a length. It's a length. We need the length. And the pi over 4 for this angle is the radian measurement. So we use the arc length. So we take the arc length and we stretch it straight. We stretch it straight. Okay. Pi over 4. That's pi over 4. Right? And what's the blue number height? The blue number height is going to be this guy. And that point, can you guys mark that point? That's the point. 1 over root 2. That's the making of sine curve. Now, let's look at what else does sine curve tell us? Sine curve tell us, sine curve is always between -1 and 1, right? Is that true? Is sine curve between -1 and 1?
Yes.
Right, you see the vertical bouncing, right? The vertical bouncing. I assume you guys got it, okay? Now, I'm gonna clean this up. Let's see how, if the sine curve is bouncing between. Because the vertical, okay, so I'm gonna expand this, okay? I'm gonna expand this to from -10 to positive 20. Sine curve, right? I just changed the scale. Horizontal, that's tell you the domain. Everywhere you see the curve, but the curve bounces between -1 and 1. It tells you what? It tells you the range. Sine of any angle is between -1 and 1. In particular, it tells you exactly this thing. Do you see that? So that picture tells you the range between -1 and 1. That's the visual, and that's the algebraic. You got it? Once you understand sine, cosine is similar. isn't it? Cosine, well, how is the cosine made? So let's look at the domain and range for cosine. Isn't that similar? Look at that. Isn't that similar? Cosine is all about the red number, right? Yeah. From the unit circle, you can see the red number is between -1 and +1, right? The smallest being -1, the largest being +1. There are lots in between. The lots in between the red numbers. So cosine is also bouncing between -1 and 1. How is it being made? How is it being made? Okay, so let's look at the cosine. Right? Let's look at cosine. So we done sine, let's look at cosine. So all I have to do, you guys already make the connection, right? This is a cosine, right? Bouncing between -1 and 1. How are the points are made? Same thing, the same way. Okay, so let's review what is a cosine. Okay, by definition, right? If we go back on the stage of we'll go back on the stage of ARD, right? The angle is the input. Cosine is the function, cosine A, and the output of cosine A is the ratio of x over r. You know what x is, you know what r is, right? On the unit circle, we have x, right? Because we chose r to be equals to 1. Okay, so those are the red numbers. Those are the red numbers, right? One red number, 1. One red number, √3/2. Another red number, 1/√2. And there's a lots in between. Don't forget, there are lots in between. So between the red numbers, there are tons of red numbers. Okay, this is 0. Every angle has a red number corresponds to it. Every angle has a terminal. Every terminal corresponds to a red number for cosine. Do you guys follow me? Imagine there are lots of red numbers in between. They just cannot be marked because that would be too crowded. So all of these red numbers, what the largest, what the smallest? So look at that unit circle. Well, sometimes you guys have one for yourself, right? Your trig teacher might have given you a red, a unit circle like that. It doesn't matter you use red or blue, but it's just in this case, we use red and blue. Now, look at what is the largest red number? What's the smallest red number? The smallest red number is -1. The largest red number is +1. Yes? So cosine pi is -1, right? Cosine 0 is 1, right? Do you guys follow me? So that's why for cosine, domain and range for cosine, sorry, I can erase those, right? So cosine A is between -1 to +1. Will these be the same for tangent? Of course not. Of course not. Right? Sine, cosine have these similarities. Okay? So now let's see the meaning of the picture. Let's see the meaning of the picture. I don't need to go as much in details as we did with sine, right? You guys got it, right? Same meaning, same meaning. So I'm just going to change a little bit. Okay, so here I'm going to make it -1. This is 5, like that. Right? So what is the making of it? So let's make sure these are comparable. These are comparable. These lengths are comparable. Are these lengths comparable? Maybe not. So this one should be the same as this one. Let me make it like this. This is more comparable, right? This is 1 and that is 1. Okay. Now, suppose, okay, let's learn how to read the graph, okay? Suppose I measure a pi over, now let's do something in second quadrant, right? 2 pi over 3. 2 pi over 3. What is 2 pi over 3?
Negative
2
1.
pi, sorry? Go ahead. 2 pi over 3. What is 2 pi over 3?
Negative 1/2.
I'm asking you the angle. If you can find the terminal of that angle. Your reply is right for cosine of that, right? But I didn't ask for that yet. But if I did ask you, you have the right answer.
Professor, do you want a reference angle or do you want the angle in degree units?
I think if you, for some of you, probably the degree would be better to understand. So let me type 2 pi over 3. What is 2 pi over 3 in degree? Sorry, my question wasn't very clear. Is that right? My bad. 2 pi over 3, what's the degree? Two pi is 360, right? 360 divided by 3 is 120.
It's gonna be 120.
120 degrees. So it's past pi over 2, right? So you measure from the standard position. And here's the terminal. And here's the terminal. Right now we're doing cosine, so we need the red number, right? We need the red number. So this is A, this angle 2 pi over 3 is A. So that's the input, right? That's the input. And what's the output? The output is -1/2, right? The output is -1/2. Therefore, we are going to measure the arc length. What's the arc length? Oh my God, this is challenging for me to mark the arc length for you. This piece is arc length. Do you guys follow me? You take this arc length, you make it straight, right? You make it straight because this is a positive angle, so it's going to be on the positive side. So now I'm going to stretch it straight. I'm going to stretch this arc length straight. Measure from the same place, okay? Arc length. Right here. Is it about right? Well, it has to be approximation, right? And what's the red number? What's the red number? -1/2. Sorry, I should use a red number, sorry. Red number. -1/2. Ah, my measurement is too off. Sorry about that. Okay, let me do it again. The orange stretched straight. So we end up here somewhere. Maybe here. Okay, it's just an estimation. If you use your calculator, you get an estimation. Okay, let me tell you how to estimate it. You type in your calculator 2 pi divided by 3. Okay, this will give you the arc length. And that arc length and -1/2 is going to be over here. That red number now is standing up because the nature of the graph, right? So this point, what is this point? this point is 2 pi over 3, comma, negative half. Isn't that similar to sine? It's just a different ratio, isn't it? Sine, you use the blue. Cosine, we use the what? The red. Is that clear, everybody? I think you got this. But the question is, how about tangent, cotangent? How about the other 4 trig functions? How about the other 4? How about the other 4? Okay, before we get to tangent, what do you think? Did you get it? So the title of today's class should be called From ARD to Domain and Graph, right? ARD to Domain and Graph. Isn't that ARD so important? Isn't that ARD so important? If you understand the graph, you can find every point on the graph. You can find every point on the graph, right? Point, whether they're special or non-special, right? Whether it's special, non-special. So let's do a non-special case. Let's do a non-special case. Okay, let's do a non-special case, shall we? Do not think the special angles are so important. They are in service to ARD. All these special angles are in service to ARD. Okay, so why we have those questions about, for basic 4A, you have questions. You can do some of those angles very easily, and then later on you have questions because you did not use ARD. If you use ARD from the first question, you will not have any question. You won't have any problem to deal with any question. Okay, that's the value of consistently using definition. And in calculus class, you must adopt this method. Okay, every exercise you do, you have to apply the definition you learned in those sections or prior. Otherwise, at a certain point, you're going to be lost. I assure you, because I have been there. I have been there. Okay. So if you just keep your focus on ARD, you will be invincible. Okay. There are more I will show you. Okay. There's more thing I will show you. So before, let's look at the non-special angle, because you always have to ask the question, now I know how to do the special angle. What if it's non-special, right? What is the non-special? So I'm going to give you a really non-special angle. And I even measure this from I measure it from I'm going to measure this from clockwise. And I ended up here, right? So I have a terminal. I have a terminal. This terminal is right here, right? And I have an arc length. This arc length is going this way. Sorry, this is a straight line. So this arc length is going to be like this, right? So what do I do? I know I have a point here, right? Even though this is not a number I know, but I just know for cosine, I'm going to look for that red number. What is that red number? Red number is the horizontal coordinate. It's going to be a negative. It's going to be a negative, right? So what I'm going to do is that on this piece, right, I'm going to have to make this one say like this, right? So what I would do, just to understand it, okay? Don't worry about the actual numbers. So I'm going to stretch the arc length. I'm stretching the arc length straight. Okay, so how long is this? I'm just going to estimate. But this is because because it's a negative angle or negative arc length, so I'm going to measure this. Okay, it's going to be a comparable, right? Something like this, right? Estimate. And what's my red number? My red number is right here. So this red is the same length as this red. This orange is the same length of the arc length. Did you get it? Did you get it? So this point, is going to have that input. The input is angle, which is the input of the input is angle. The output is what? Is a ratio. Cosine ratio, which is right here. Do you guys follow me? Do you follow me?
Yes.
This piece, this part of understanding is essential. Do we see that they are directly coming from definition? Nowhere else. Nowhere else. In fact, the definition, the ARD, these three elements are the three pillars of trigonometry. If you go through the textbook, right? You go through the textbook. These three are three very important concepts. You have to constantly think of them. You have to constantly think of them. Angle measurement, reference angle. If you think in this setting, you'll be invincible. You will be invincible. Okay, so without further ado, and today I don't plan to go much deeper into tangent, and we will do tangent tomorrow. Yeah, we'll do tangent tomorrow. Today's class ends at 35, right? Ends at 35. So I'm not going to go further. Do you guys have any questions?
Professor, I want to see if I can summarize this part you taught us. In the picture here, I see you're converting the polar into rectangular based on those terminology like angle, right? Angle and the arc given, then be converted to X and Y. So is that correct? If you want to summarize it?
The arc length, right, is the X. Okay, is the input. Is the input. I don't want to use X confusing people. But on this curve, on this cosine curve, the input is the input for cosine. The output is the ratio of cosine.
In the unit circle, R is 1, that's why it's just X, otherwise X over R, yes.
Right.
Thank you, Professor.
Mm-hmm. Thank you for your contribution. Anybody else who wants to do some summaries here? So last but not least, so maybe we do a summary, right? For sine, cosine. We have the cosine curve, right? We have the cosine curve, and we have the sine curve. Of the sine curve, right? So I'm going to make some adjustment because you can make so much adjustment to these. So just make it a little bit more manageable, okay? I'm just going to make it more manageable for cosine. So this is going to be 25 7. Okay, so these are more manageable. And in terms of the rules of the function, right? The input are angles. I emphasize the input are angles for these functions for a good reason, because very soon we're going to do inverse function. Okay, we're going to do inverse function. So we're going to have a whole bunch of other discussions. Okay, so for cosine, there are also, you know, it's another set of discussion. Okay, you can see they're bouncing between -1 and 1, right? And we have talked about domain. So let me just put it here, domain. Domain is all real numbers in radians. So far, I have not spent much time with you guys just specifically cover domain and range. Okay, but today I'll be giving you homework to reflect on these things, Okay, so I'm gonna just trim this because we have that. This is what we have done. We've done domain and range. And then you say, hey, when we, how about x-intercept, y-intercept, and all of that stuff? They're coming your way. So range, okay, the forms of range, right? Between -1 and 1. Okay. Or the absolute value less than or equals to 1, or -1 +1, right? For range, for cosine is similar. Cosine range is similar. Okay, and one sentence description, very, very important. You're gonna need this narrative all the time. Okay, domain range, one sentence. Okay, you can say this for any real number A. The same is true for cosine. These narratives, you will hear me sound them out from time to time to make my argument, Okay, the next one, so let me make this just a little bit smaller. Summarize, okay. I use this one, which is another very useful expression, okay, for any real number A. Okay, for any real number A. All right, you guys, we have much more to do. We still have more to do. Recall what we done with the other functions before trig functions. What did we study? We studied the rule. Look how much time we studied the rule. This rule is a little bit more complicated, right? You have to set the stage. It's not so straightforward. Once you set the stage and you look at the graph tells us all these things and you put them together in the domain and range setting. And there's these two, you know, as you guys know, they're periodic functions. They're periodic functions, right? And we haven't touched the x-intercept, y-intercept, right? And of course we can tell, but it looks like there are a lot of x-intercept, there are a lot of x-intercept out there, right? So how do we find them? How do we find them? Okay, but that's the end of the class, and I will see you guys tomorrow.
Thank you, Professor.
Thank you. I will give you guys homework, okay? You're gonna have some homework. Great job.
Thank you. See you tomorrow.
I'll see you guys tomorrow. I'm looking forward to it.